Hello friends, welcome to my channel. My name is Amrit Purandare. In this tutorial, we are going to learn the second principle, that is open and close principle. In the last tutorial, we have already seen what is solid, what is the acronym of solid, why to use solid principle, advantage of solid principles, and we have also seen the first principle, that is single responsibility principle. This tutorial is targeted for the second principle, that is open and close principle. So let's get started. As per the definition, it says software entities should be open for extension but closed for modification. Here, software entities means all the classes or the modules which we are going to develop. And there are two parts in this definition. The first one says it should be open for extension, while the other one says it should be closed for the modification. So let's get started by and learn what do we mean by open to extension. When we write a software component, it should be open for future extensions. This means inheritance should be possible. A class can be considered to be open if its functionality can be enhanced by subclassing it. That means by following the inheritance. Whenever we are creating a classes, it should stick to the current behaviors. Also, keeping in mind that behaviors could always change and evolve. We should anticipate what could change and what could be extended. And by considering all these things, we should design our classes. So that is what I mean by the open to extension part. The second part says the classes should be closed for modification. So when a class or module is said to be closed if it's available for use by other modules without modifying it. Basic requirement for a class to be closed is all of its fields and functions should be finalized and they cannot change. The implementation of any software entity should be closed for modification. The implementation means our compiled code. A class can be considered to be closed if its runtime or a compiled class is available for use as a base class, which can be extended by child classes whenever required. If the behavior is changing, we are not allowed to change how specific entity works. However, we just need to extend it and add the new behaviors. So now let's get started with the some code that violates this principle. As part of an example, I am going to design a small utility which will give us the areas for a shape. So for example, let's say I have a rectangle class which is a shape, and I'm going to create a utility area calculator which will have the method which will calculate the area for the shape. So in our case, a area for a rectangle. So far this design is good. Now let's consider I have added one more class, a circle. So I will create a class circle, and I have to modify the area calculator utility class, which now will have one more method which will return us a area for the circle. So far so good. Now let's consider I have one more class, one more shape which is a pentagon. So now I again need to modify the area calculator utility, and it will continue as we keep on adding the shape. So this class area calculator, it's not closed for modification. Whenever we are adding a new shape, we have to go ahead and add the utility for that class, and the consumers of this class will have to update their libraries which contain area calculator class whenever we are changing it. So this is not the good practice. Also, this solution is not extensible, as for each shapes we are adding the new methods in the class. So how to fix this? So to fix this, we are going to use the interfaces. I will create a interface shape which will have the utility to return the shape. So all the shape class will inherit from this shape interface, and they will return their areas. And from our utility method, uh, area calculator, what we will do, we will create only one method which will take shape as argument. Now it's taking a base class as argument and not the child classes, and it will just return a area. So this design is now correct as per the open and close principle. So first thing, this design is open for extension as more shapes can be added without modifying any of the existing code. We just need to create a new class which will implement the shape method and which will override the calculate area method. We don't have to modify anything. This design is also closed for modification. If we see, area calculator class is now complete with respect to area calculation. It now caters to all the shapes which we have today, and it will also caters all the shapes that will be added at the later point of time. So this is how the solid principle works. Now let's go ahead and check the advantage or the benefits we are getting from the this principle. So the first thing, this principle needs to be done in the development process, but it helps us in the maintenance. So if we design our code keeping in mind this principle, then all the future modifications, all the code changes that we will get in the maintenance phase, there will be a very less changes, and that will not impact the existing code or the external applications which are using our libraries. It minimizes the impact of changes to our application code. That's a very big achievements, and this principle, open and close principle, helps us to design the libraries. So these are all the advantage of the open and close principle. That's it for this tutorial. If you guys have any questions, comments, please post it. I will try to answer them. Thank you.